Joining us for our RIB's webinar series on BIM and VDC, and this is part 1, Improving Project Delivery through VDC. Before we get started, just want to go through a little housekeeping. Everyone during the webinar will be placed on mute, and then at the end of the session, we'll have a question and answer. There's a question dialogue area in your GoToWebinar. You can submit your questions there, and we'll answer them at the end of the discussion, and we'll take them in the order that they are received. We'll also have this webinar available on a video, and we'll get you that information once everything's complete, and we'll send you a link to view the webinar as well. Again, I'd like to thank you for joining us for Improving Project Delivery through VDC. Today's webinar is presented by Rex Tate, Assistant Vice President here at RIB. Rex has received his Bachelor of Architecture degree from the University of Tennessee. He has also received Virtual Design and Construction certification from Stanford University. RIB is a member of SIFE, the Center for Integrated Facility Engineering, and Rex is our representative there at Stanford for SIFE, and Rex is also a lead green associate. So with that, I'd like to welcome you again, and Rex, take it away.
All right, thank you, Michael. We'll now begin our seminar, and we'll simply step through the initial concepts of what VDC and BIM are all about and how it can be used to aid in project delivery. Okay, this is part 1, and we will now proceed. Okay, what we're going to talk about is defining what is VDC and what is BIM, what are they all about. We'll look into waste in architecture, engineering, and construction industries, and the reason there's so much waste in AEC. And then we'll take a look at 3D models and learn a little bit more about those and how they're used within the VDC process. And then we'll also talk about LOD, the level of development of objects within a model. Okay, what is BIM and what is VDC? Okay, BIM is Building Information Modeling, and you can see it's a digital representation of a physical building. Okay, BIM is a process of managing construction projects with 3D models. Okay, we're going to look also in a moment or so about what BIM is not. Okay, now the VDC uses BIM. BIM is a portion within VDC. We'll look at the graphic in a second that will hopefully clarify how the construction processes in VDC and BIM all work together. Okay, VDC is the management of the models for construction projects through analysis. It's heavily based in the gathering of metrics on projects. The use of co-location, that is people working on a project, and not just the designers, not just the contractors, but all the stakeholders, working together, physically located in one area for ease and quickness of communicating with one another. This tremendously aids the improving of the delivering of the project. Okay, think of VDC as a way of doing things in construction. Okay, now let's look at this to understand how all this fits together. The light blue oval, think of that as the whole world of construction, and also the sizes of these ovals do not represent any kind of percentages or anything like that, because VDC currently is not that tremendously used as a % of delivering construction projects, even though it is growing and will grow over time. But again, if we look at the light blue oval, and that's all of construction. Within that, we have VDC. That is one method of organizing and delivering projects. Okay, BIM is a part of VDC. In a later lecture, we'll go into all the different components that make up VDC. But for now, let's just understand that BIM is one single portion that makes up VDC as a whole. And 3D models, that's not the totality of what BIM is. 3D models are a part of BIM, such as that BIM is within VDC. Okay? Now, let's look at some information on waste in the AEC industries and compare it to construction or to manufacturing. This is a tremendous difference in the two industries. If you look at on the left at the pie chart, you can see that 57% of the money that goes into a construction project is defined as waste. Okay, anything that is cannot be defined and measured as value adding, okay, or a support activity, is money being spent. We're going to call it waste. Okay, construction 57%, manufacturing only 26%. But then another big thing to see here is that in construction, 10% of the money goes towards value adding, whereas in manufacturing, it's 62%. Okay, let's find out why there's such a discrepancy in these two different industries. Okay, now let's look at BIM and see what BIM is not. BIM is not just software you buy from a store. You can't have a project manager or somebody like that, or an officer in the company saying, oh, let's get into BIM. I want you to go down to the store, get on the internet, and buy me some BIM. Okay, it's not just the software. Okay, BIM is not just the 3D model. Okay, if you're working with Revit or Tekla building a 3D model, that's not all there is to BIM. So you're not BIMing if a model builder is sitting there working away. Okay, he's doing a part of BIM, but he is not doing the totality of what BIM is all about. Okay, I'm sure everyone has heard about clash detection. Okay, that's a good area of BIM, but that's not all there is to it. Okay, again, I just wanted to get these things made clear. Okay, let's back to waste and problems in construction as compared to manufacturing. If you look at this chart, and this was put out in the year 2005, there were probably other versions of it put out a little bit earlier, but beginning in 1964, they set a baseline at 100% and put manufacturing and construction together. Then over the years, they began measuring the productivity index of both of these industries. You can see how manufacturing productivity has risen over the years. It's slowly but surely and increasingly improved over these years. However, let's look at construction. It has gone into decline since the baseline year. Again, why is this? Okay, and we'll find out in a minute. We'll find out some contributing reasons. Okay. Again, here's some information from the Harvard Business Review. And in construction, this is all construction here. In the studies done on a mini-series of construction projects, 71% of them were late, 21% were on time, and only 8% finished ahead of schedule. Again, why is this? Why is there such problems? Let's look at the budgets on the right-hand side. 73% of construction projects end up over the planned budget. Okay, only 12% cost less than was expected, and only 15% were within the original projection. Okay, one of the reasons for this is that construction done by conventional methods is a fragmented process. Okay, this fragmentation is just one factor, but it is a factor in the reason there is so much waste introduced into construction projects, because all of these different important groups within the project are all working independently. Okay, VDC is a process that can bring these groups together for increased communication, so that the waste and the lateness in the schedule can be reduced. Okay? Okay, manufacturing has a culture of measurement. AEC does not. In a later lecture, it's probably the third lecture, we'll get into something we're calling a concept of parts that we're developing at Stanford University, and that's going to bring things more into line with what the manufacturing sector does, in that all these portions and parts and individual things that are used in a construction project are extremely defined, not as they are currently. In manufacturing, there is a item called a BOM, a bill of materials, and it's heavily used there, and it is part of the culture of manufacturing, whereas that is not true for construction at the present time. Again, that is something that construction will be moving towards to increase their productivity and their efficiencies. Okay? Now, how can they become better at building? Okay, how can VDC versus traditional project delivery methods improve things? Okay, your traditional, conventional delivery methods are design, bid, build, construction manager, design, build, and multiple prime. Okay, IPD, integrated project delivery, can use VDC as a process within it, and that will tremendously improve construction processes. Okay, why do these traditional construction delivery methods have so many problems versus IPD? Even though IPD is very complex and it's difficult to achieve, but it does get results. Okay, how do you procure the services of the contractor, the subcontractors, the engineers, the designers, etc.? Okay, there's three major methods. There's price-based, and that is usually the job is put out for bid. The bids come in and they select the low bid. Okay, and then they may or may not negotiate with the price after a bid is accepted or whatever. Then there's the best qualifications. Okay, bids are not put out. The owner determines whether contractors are qualified to perform the job, and then the price is negotiated with them. Okay, and then there's a combination of the two, and we'll call it best value. Okay, it allows qualifications to be considered, and then there is some bidding, there is some negotiation with the price, etc. So if we combine the first two, the third one is the result of that. Okay. A problem with the waste and the reason projects are late and things like that is there is not early collaboration between the designers, the contractors, the subcontractors. They're not even chosen yet in a design, bid, build method. Okay, the design is done by the architects without contractor input or involvement. Subcontractors have not yet been chosen because the contractor has not been selected because the bids are not put out yet. Yet the design has gone on. Okay. The term collaboration allows input from all these different parties on the project. Okay. The design, bid, build method, though it's inherently adversarial. Okay. And this does not allow for a collaborative environment. Okay. If you can define and know about a project's conditions at the very beginning, and this means the design process, the concept process, that's going to help define the outcome. Whereas if these conditions are not defined before the contractor begins his work, you're going to have problems, and the outcome is not going to be as good as it could be without the early collaboration. Okay, DBB does not allow early collaboration. That means you've lost the impact of early involvement and communications between the different parties within the project. Okay. Again, the adversarial environment is a big problem with the DBB method. Okay. With VDC, like I said earlier, the design process is not produced independently. Okay. However, even with the collaboration, we don't want to have a project that's bad design by committee. You've heard the term, oh, a camel is a horse designed by committee. Again, the collaboration does not mean it's a committee and there's mass confusion trying to get something designed. It's all collaboration, working together, input, free communications, working with the 3D model, visualizing things, getting the job done properly using these tools. Okay. IPD with VDC is a complex thing, but it is a very beneficial team agreement. Okay. Think of IPD as that hard, difficult, but beneficial team agreement. Okay. VDC methods could be used partially on a project, but if they're not used 100%, you're losing a lot of the advantages of it, but you can, get some benefits from partial use of it. And a lot of contractors that aren't familiar with or have experience in VDC methods may adopt VDC incrementally and therefore just use it, different portions of it at the beginning at small areas of a project, and the next project they use some more and the next some more as they gradually adopt the whole thing. Okay. You don't want to try to do something you know nothing about and then you completely fail at the project. it can be an incrementally adopted method. Okay, let's look back at the project delivery types again. IPD using VDC, that's going to use that best qualifications method for procurement of the designers, contractors, subs, engineers, etc. Design, bid, build is going to use the low bid method. Okay, a lot of times that is required by law in order to help eliminate the award being made to someone that's based on that they know them and they like them and they want them to have a job but they're not really qualified to do it, and that's not the way to do it. The low bid method is required in order to avoid things like that. And the other two, the construction manager delivery type and the design build delivery type, typically use the best value procurement methods. Okay, we're now going to begin to look at some 3D models and objects and define some things about them and learn a little bit about 3D models and get an introduction to model objects, models as a whole, and so on. Okay, a 3D model is going to consist of many, many, many elements or objects. Those two terms are interchangeable within the whole model. Okay, and each of these objects represents something within the project. Okay, and each of these model objects can be loaded with that information listed over there on the left, plus much, much more. Okay, this is just a partial list of some of the information that can be loaded within the objects in the model. Okay, you know, the equipment needed to install that particular item, material information and cost, the crews needed to install it, the labor and rates, wages, the sizes, the weights of that construction item, any transportation requirements that are needed for it, all kind of stuff. Plus, we can put in some scheduling information in that, and we'll see how that gets used in the VDC, in the BIM process in a moment. Okay, one of the big values of BIM models is the concept of visualization. Okay, you're looking at a 3D representation of the project and not just the flat 2D plans, even though the flat 2D plans can be extremely helpful in conjunction with the 3D model. Okay, you can generate 2D plans, sections, things like that from the 3D model. Okay, you can do walkthroughs and fly-throughs and go inside the virtual building. You have this wonderful viewing ability of the project by looking at a well-done 3D model. It helps you possibly see any problems that may arise in the actual construction process within the model, and so you can take steps to correct things prior to actual physical construction. Okay, and that would, again, that helps save rework, that is the tearing down of some construction items already installed or placed and building them again. Okay, that's again part of all that waste we talked about earlier. If you do it correctly the first time, that's better than not doing it correctly the first time and having to redo it. Okay. Again, 3D models help us visualize and see the project, get the concept of the whole thing in our minds and help see any design problems or problems that may arise during construction that can be corrected within the model now instead of on site later. Okay, you will hear of the term LOD. Okay, there's two definitions of that, or two wordings of that. There's level of development and there's level of detail. Okay, think of and level of development is really what we're going to concentrate on in a few minutes here. Level of detail is the input. Okay, that is how much detail did the modeler put into a particular object. Okay, the level of development, that's the output. Okay, that's your ability to give reliability to all that information that was input in the model and use it. Okay, and it's based on the degree with how accurate all that model's contained information is. Okay, that's the level of development. Okay, so just think of LOD, level of development, as output, and LOD, level of detail, as the input. Okay, the AIA has published a series of levels and defined what they each mean. Okay, this is an expanded list. The AIA, their official levels only go 100 to 500. This list is slightly expanded. Many, or not many, some contractors have in-house enhanced the AIA protocol list of levels, and they've added 450. That notice that there's 3 subsets here on level 100, level 300, and level 400. Okay, the 150 and 350, those are official AIA protocol levels. Again, they only go 100 to 500, and they don't have that 450. I've seen the 450 added by a well-versed in VDC contractor, and I've also seen other contractors take level 500 from the AIA and divide it into 500 and 600. Okay, level 100, that's your those are useful and represent the conceptual design level. Okay, level 200, you've moved up into schematics. Level 300, now you're in design development. Level 400, that's your construction documents. If you have a model whose necessary objects are at level 400, then the project can be built. Okay, you can use those to actually construct the project. Okay, levels 500 and 600 are post-construction levels. Okay, think of level 500 as an as-built, and that's your current conditions. And when you move into level 600, it contains all the necessary product information you need for operations and management of the facility. Okay, so we can see that by defining what the LOD of a particular model object is, you can see what it's used for and how much more work it needs to get to additional higher levels. Okay, anyway, moving from 100, 200, 300, 400 on up, you can see that models can be defined by their level. But yeah, let me make this clear. A given model made up of many, many objects, each object in there is going to have its own level, its own LOD. So a given model is going to consist of objects of varying levels. varying LODs. Okay, the LOD is on the object, the element level, and not the model as a whole. Okay, even though the model can or cannot be used for certain items or certain purposes until the sufficient or the correct models or objects within the model reach certain levels. Okay. Now, some objects within the overall model never need to rise above, let's say, level 300. Okay, that's not a bad thing. It's just you don't need to fully load every single object in there to use the model as a whole for the construction document purposes. Okay, so you don't. The LOD is not the a tag you put on the entire model. It's a tag that is placed on individual elements, objects within the model. Okay, so here's something that's moving from a level 1 to higher levels. So when you see generic masses, some spaces defined, all spaces defined. Okay, and let's say you have there's no such thing as a LOD, a level of development of 0, because if an LOD 0 is an object, then that object doesn't exist yet. Okay, it doesn't exist until it's at least some kind of thing at a level 1, level 100. Okay. Here, let's talk about again to get an idea about these various levels. Okay, level 100. That is at that point, it's just a placeholder. It's just there's a thing here, but we really don't know what it is. You just put this object in the model. It's there, but there's no definition for it yet. At level 200, we know about where it's located and that it's about this size, but there's nothing real specific about it. At level 300, we've now given it some functions and some characteristics. We know what it's supposed to do. We know about how big it is, but not perfectly exactly. But, and again, we know enough about it, but we don't know enough to properly construct it yet. Now, when we reach level 400, we know enough about it that we can make it now. That is, we can build it if this represents a construction item on the project. And then level 500, 600, those are post-construction for maintenance and things like that. Okay. Again, this is the walk through the various levels. That level 1 is conceptualization. Level 150 is within level 100, and we'll call that space planning. Level 200, criteria design. Level 300, detailed design. Level 350 is enhanced detailed design. Level 400 is the finished construction design. At level 500, we can do facility handover, but we can't do O&M yet, operations and maintenance. At level 600, now we can use the model for facility management. Okay. Here, let's look at a few examples of models and objects at various levels. Okay. Here's something. It's conceptual. It's initial idea. We kind of knows a little bit about what it's going to be and where things are going to be, but it's just objects, just stuff at this point. Again, giving us a conceptual idea. Level 200, we know a whole lot. We're way beyond the sketching time, but we still don't have enough information within it to actually build it, but we do know a good bit more about it. Okay, level 400, we can build it based on this model and all the information within the objects. Okay. Okay, here's level 500. Okay, we're looking at it and it's pretty, but do these objects contain the information we need to actually have an as-built document? Okay, you have to look within the objects to see what information is contained within them. Okay, let's look at this example and see, again, following the increasing LOD. Okay, at 100, we know we have a vertical element, and it's there, but we don't know what it is. We don't know what material it's made of. We don't know if it's structural or architectural or whatever. We just know that there's a vertical element present there. At LOD 200, we now know that it's a steel column, and it's kind of specified size-wise, but that could change. And as we move to 300, we know exactly what size it is. We know exactly its coating. At 350, we know it's on a base plate. And at 400, we know exactly how the base plate is secured. So we know we've got the vertical element that is a structural steel column of a specific strength, size, coating. It's on a base plate, and we know how the base plate is secured. Okay, so again, we've gone from just knowing that there is a vertical element located about here to the level 400, and to which we know a sufficient amount about it to get it built and installed. Okay, again, here's a series of levels we can look at to, again, get an idea as we move from 100 to 500. Okay, and we go from left to right. We really, at the conceptual stage, we don't know that that's a chair. We just know that something's going to go there. Now we know we have some kind of seating, but we don't know anything more than that. And then when it's defined, we know there's a chair there, but we don't know exactly what brand or anything like that for maintenance purposes. We know where it is. We know it's a chair. Okay, and then again at the end there, we know the brand of chair, the size, everything about it, the material about it, where it's located, when it's going to be installed, and so on. Okay, thank you. We have completed this portion of the webinar. Michael?
All right. Before we have our short question and answer period, don't want to keep you guys any longer than we need to, but I would like to remind you that Part 2 of our webinar series, Part 2 will be titled Model Management. That will be about a month from now. It'll be on Thursday, June 25th, the same time, 1 p.m. Central Daylight Time. So we hope to see you for that. And then we're looking at probably 4 parts to this series on BIM and VDC. Right now, we'll take your questions. If you have any questions, you can enter them. There is a question and dialogue section there in your GoToWebinar. You can also use the chat dialogue if you'd like to pose any questions, and we'll answer them to the best of our ability. All right. Well, it looks like everything was pretty straightforward. Don't see any questions so far. So with that, we'll bid you a good afternoon. And again, we thank you for coming. And don't forget, Part 2, Model Management, Thursday, June 25th at 1 p.m. Central Daylight Time. Check your emails. You should get reminders on those. We'll also should get a reminder as well to view this recording of today's webinar. And again, we thank you for coming. Everyone have a great afternoon. Thank you so much.